Okay, so it is definitely possible to get an idea of what strain the patient was infected with. There's no doubt. In New Zealand, they're doing that. Every patient has their viral sequence done, and they're backtracking to see where that might have come from. It's not even, oh, who did you talk to? Where did you go? They're sequencing the virus on each patient. Why? Because they're infected. Their most recent outbreak was 24 people, not 40,000 a day. Try doing 40,000 viral sequences on plasma a day. No. Okay. So yeah, good question. Any other we should catch up on or keep going? Okay. So go back to this. All right. So we've had, where did this idea come from? We have had a therapy called intravenous immunoglobulin for a long time. And what we do to homogenize the effectiveness of the IgG is that you take it from 10 to 15,000 patients and you pool it, and then it's homogenized, and it's usually given to patients that have suppressed immune systems or some sort of antibody production deficiency, bone marrow suppression, and things like that. And this can prevent them from getting ill generally. So you're not taking IgG that is specific to a recent infection or disease like COVID, but you're just taking 10 to 15,000 healthy individuals who have regularly lived a normal life of getting sick and getting better from normal daily infections and common cold and flu and whatever, sore throats. And when you pull that all together, what you have is an effective pool of IgG that will help to neutralize common infections in patients that can't produce it themselves. Okay, so this IVIG is not specific to a disease. It's just to bolster the immune systems of people who can't produce this effectively for themselves. All right. So we know the exact dose, so 400 milligrams per kilogram of body weight. You can give it over a 3-week interval. And it does a lot of great things. So what it does, I'll go in order here. Hold on one more second. Sorry.
That's where John comes on and does this.
Bernie, you're killing me.
You've got the age, Karen. I've got the dancing fingers for John.
So, okay, so this is very technical, so I'll try to go fast. The Y-shaped antibody, which you saw, hold on. This is the Y-shaped antibody, right? That's Y. That is actually in 3 space, looks like this in 3D space, okay? And it is divided into the upper part of the Y and then the stick part of the Y, right? Okay, so this is floating around in your bloodstream in massive quantities, but it's so tiny that it's a tiny protein, but it does different things based on what part of the antibody we're talking about. So the upper part is the one that actually binds to viruses or binds to bacteria, and then that binding can do a number of things. It can neutralize the bad part of the infectious agent, like the spike protein or something that is used by the bacteria to cause damage to your cells. Or it can also sequester other parts of the immune system to come into the fight. Okay, so if it binds and then the bottom part comes along and binds to other parts of the immune system, like white cells, okay, then it activates a whole another level of immune response. And this is important because it's not just that, I mean, look, so when we talk about convalescent plasma, we're delivering plasma, which has a bunch of other stuff in it. We're delivering antibodies. So the majority of the active antibodies are a result of the most recent infection. So you got to gather it at the right time. You got to gather that at the peak of when those antibodies have been produced in response to the infection. If I take it too early, like, Terry gets sick, recovers next week, and then I'm like, Terry, let's go. Got to get your plasma donated. Well, it's not ready yet. Okay. It's going to take 14 to 16 days for him to have the requisite amount of antibodies to be an effective donor. It's, and then it peaks over to the next 2 to 3 weeks. And then it starts to kind of settle down into a memory status. That's what protects him from reinfection from that strain for the next couple of months, right? If I take it too early, there's not enough there. If I take it too late, then also I have a suboptimal amount of antibody, all right? So are we making sure that everybody we take convalescent plasma from right now is that plasma is being taken at an optimal time? What's your guess? No.
I'm going to say no. We can't even, we're not even collecting our data in a uniform way.
Yes.
So I would make the assumption that we're not collecting our plasma in a uniform way.
Correct. So this is what frustrates people like me and others, that complex problems often require complex solutions. Simple problems can be solved simply, but you need to know what the difference is. If you assume a problem is simple, like we'll just give convalescent plasma to everybody, then the results are not going to be as expected, all right? The details of this are very detailed, for lack of a better word. So, this is going around so this process here that I'm showing you of engineering the right amount of IgG for the very specific disease that you're trying to tackle, using a platform that's reliable and producing antibody that's specific and in the right concentration. This is ideally where we should be paying a lot of attention and trying to get this up and running. Good, very good, and we've got a good start here. This got us through with some patients and helped a lot of patients, it seems. We need to know more about it to say that it's truly effective. Otherwise, we're just pushing it, and it's not fair to everyone. Okay. All right, that's what I've got on convalescent plasma.